Hello everyone, my name is Mohan. I'm recording this video as part of my project, Duke University's AI Product Management Specialization. The problem we are considering for this project is the global food scarcity, which we are anticipating by 2050. When we take a look, the population of the world is going to increase or reach by 10 billion by 2050. When we look at the current projection of the food production, this requires a 70% increase in the food production what we are dealing with right now. And when we look at the current projection, we would end up with a gap of 56 percentage. There are multiple factors impacting it. One, the limited number of landscape we can call out. Additionally, if we take a look at the climate impact, drought, which is getting more and more into various regions. When we take a look, both the business impact as well as the feasibility falls under the high quadrant, which is a compelling reason for us to move forward with solving this problem via machine learning. So, in a nutshell, we are dealing with the problem of 56% food production gap, where farmers and government bodies are interested in knowing what kind of solution we have so that we can get ready for the growing demand. And our ML techniques is a viable solution for us to move forward. And we also consult with the local bodies and the scientists or some organization around those areas related to agriculture, where we meet with the experts or tap some talents around that understand their factors as well, or the learnings they have. So our outcome should be measured in a way that, hey, is that economic of if we look at the economy of a farmer, are we improving it by 20-30%? Also, we are going to see whether our yield is doubling. Additionally, we are anticipating the resources which we are going to use for these kind of farming, we call it a smarter farming, is going to reduce by 30%. We're just going to use only if required at the right time. Okay, how are we going to approach this as a solution? So, in my view, we are going to apply the predictive methodologies in applying the deep learning techniques like CNN or RNN, with the help of the satellite images, the weather forecasting details, and the data which we are going to collect as part of the sensors kept at the soil. Solution approach. How are we going to validate this? Validate our solution whether it is working or not. So we approach this in a cycle. As we learned, we have a hypothesis, and in order for us to test with the hypothesis, and we want to have a couple of or engage with the initial set of users, try our solution, analyze our learning. Then once we completely understand the data sets which we collected, and once we make a model which is going to make the right prediction and suggest as what we need to do, then it's time for us to extend it to another set of users or a pilot set of users, and then and target the production environment, and then kind of keep this cycle moving. In a specific example of our problem, what we intend to do is we'll start off with the sandbox environment, collect all those information, develop a model, come up with the predicted outputs, then take that. Once we are comfortable or once we are very much confident, then approach a set of pilot farmers to implement this. Just select various zones and apply this. It may take close to 9 to 10 months. Let's completely invest ourselves in the pilot, see how it is working, and we keep learning and refine our model. And if required, we'll add the additional data we collected to train our model. Once we successfully concluded our pilot, then it's time for us to go with big bang, kind of move it to production at a scale. That's the approach we are going to go with. And since we are moving in an iterative way, we have validation and each step whether we are moving in the right direction or not. Design our system in a way from pilot, when we are getting into a scaled production launch, we don't struggle with our way of system design. So we approach this in a three categories. One, hey, where are we going to keep our devices like sensors and other things, like, and then how is this model going to learn about all those things? Is it going to be an online learning or offline learning, right? And then we also looked at, okay, so when the model is collecting all these data, how are we going to predict, is it a batch approach or an online? When we look at it, so when we look at this model, we are going to keep our data centralized in the cloud environment. So while we have various sources on the field to kind of collect all these data, but these data are going to reside in the cloud, and continuously go ahead and ensure that the data is processed. In our scenario, it's a batch process on a daily basis. It will run the model and ensure the prediction, and make sure if there is any sensitive information. For example, if you are expecting a rain, then it would notify the farmer or our user within a high priority alert. Similarly, we can kind of have any insects or some kind of plants infected with the diseases. Those kind of alerts can be immediately triggered to the farmer on a daily basis. That way, respective actions can be taken. The solution, it is important for us to anticipate what kind of potential risk we are dealing with. Um, there are multiple risks, but we're broadly classified into four categories. One, we call it as training skew. The data which we used, those are all traditional data. We might not have a complete data specific to that region or that country or the area we are dealing with. That and continuous change in the climate and the drought nature, since it is changing, what we trained versus what we are seeing actually on the ground may not be the same. And the latency, the prediction which we are understanding and delivering to the farmers, so there may be, depending on a huge data which we are collecting, there may be some latencies. In this case, we considered that and ensured our system is designed in a way. So in our example, in our example problem, we are not going to see a latency. However, that's one of the factor where we can keep a close watch on. And the data drift which we mentioned, so during the training we might have used the static training set, right, which is standalone, and this data changes every day. It's a dynamic set. So concept of drift is another factor which we consider as a potential risk. When we train the data based on the training data, the prediction makes sense in the sandbox environment, but in the production environment, when we try to do some over the period, when the data, when the system or a model learns new data, um, seeing start seeing new data, whatever it learned versus what it is seeing on the in the production may be different. So that completely changes the prediction, which may not be relevant. As long as we can retrain our model in a limited in a frequent way using the new data, this can be avoided. All about this particular project. So we discussed about the problem and the ways, how getting this risk, and at the same time, we also discussed about our solution approach, and then how can we implement and validate what kind of outcome metrics we are going to deal with. And then we also discussed about the potential risk and how we can avoid that in future. Thank you so much. Appreciate your time.